Here in chapter 5.4, we will study the sum and difference formulas. What are the sum and difference formulas? Well, they are another set of trigonometric formulas for you guys to work with and utilize. All right? Notice that in each of these formulas, we have either addition or subtraction occurring inside of each one of these trig functions. All right? Hence the name, the sum and difference formulas. Now, the sum and difference formulas allow us to extend the scope of finding exact values when evaluating trigonometric expressions. All right, so we're going to go through, I'm going to show you some relationships to the unit circle, relationships to angles that aren't on the unit circle, as well as utilizing these sum and difference formulas when proving identities and solving trigonometric equations. So a lot of what we have done already, just building on it using these new formulas. Important to know, you are not responsible for memorizing these formulas, okay? All of the formulas from section 4 and section 5, I will give them to you. They will be provided, but it is your responsibility to know how and when to use them. Okay, so let's take a look at a few examples here. First off, relating to our unit circle. Find the exact value of the following expression. Here we have the cosine of pi over 4 plus pi over 3. Notice that we have addition inside of this trig function. We have two quantities connected by addition. Well, because we have addition inside of a trig function, not a bad idea to use our sum formula for cosine. Cosine u plus v equals cosine u cosine v minus sine u sine v. Well, utilizing this formula, notice we can think of this first quantity, pi over 4, as being our u, and this second quantity, pi over 3, as being our v. We can rewrite the expression as the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. And the good news is each of these angles is on the unit circle, and we know what the value of each trigonometric quantity is. The cosine of pi over 4, that's root 2 over 2. The cosine of pi over 3, that's 1/2, minus root 2 over 2 times root 3 over 2. We know each one of those quantities. Root 2 over 2 times 1/2 minus root 2 over 2 times root 3 over 2. Now we can begin to do the algebra to simplify. Well, to multiply two fractions, we multiply numerators and denominators. That gives us root 2 over 4 minus root 6 over 4. Recognize here, if I'm multiplying root 2 times root 2, root 2 times root 3, I can combine those into a single radical, root 2 times 3, both underneath the radical, giving me root 6. So we have root 2 over 4 minus root 6 over 4. Well, the nice part about these two fractions is that they have a common denominator, and when we have a common denominator, all we need to do is subtract our numerators. The denominator stays the same. Now, there is no way for us to combine root 2 minus root 6, so we just leave that as our solution. All right, root 2 minus root 6 all divided by 4. That is the cosine of pi over 4 plus pi over 3. Well, what did we actually just find? We were finding the cosine of pi over 4 plus pi over 3. Well, if we were to try to combine these two angles inside of our trig function, we would need a common denominator. That would be 3 pi over 12 plus 4 pi over 12, which is 7 pi over 12. This is actually the cosine of 7 pi over 12. So these formulas allow us to evaluate trig functions of angles that are not specifically on the unit circle, but might be the sum or difference of two angles that are. Let's look at another example here. Let's find the sine of 5 pi over 12. Now, 5 pi over 12, this is not one of our special angles on the unit circle. However, is it a combination of angles that we do have on our unit circle? Let's find out. So we go to our unit circle, and I find the easiest way to do this is just to begin to rewrite each of the angles with our common denominator. Our denominator in this case is going to be 12. So pi over 6, I can rewrite pi over 6 as 2 pi over 12. pi over 4, I would multiply this by 3 over 3 to get a denominator of 12. That gives me 3 pi over 12. And notice 2 pi over 12 and 3 pi over 12. If I add those two together, I get 5 pi over 12. So the combination of adding those two angles will give me 5 pi over 12. That is pi over 6 plus pi over 4. So the sine of 5 pi over 12 is equal to the sine of pi over 6 plus pi over 4. Now we can use our sum formula for sine. The sine of u plus v is equal to sine u cosine v plus cosine u sine v. Using the formula, this turns into the sine of pi over 6 times the cosine of pi over 6 plus the cosine of pi over 6 times the sine of pi over 4. The good news is we know how to evaluate each of these quantities. The sine of pi over 6, that equals 1/2. The cosine of pi over 4, that's root 2 over 2. The cosine of pi over 6, that's root 3 over 2. The sine of pi over 4 is root 2 over 2. That leaves us with 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. Now we can begin to simplify. Well, we multiply numerators times the numerators, denominators times denominators. That gives me root 2 over 4 plus root 6 divided by 4. We have a nice common denominator. We can combine those two fractions into a single fraction, giving us our final answer, root 2 plus root 6 all over 4. That is the sine of 5 pi over 12. Let's try one more. Find the exact value of the following expression, the tangent of 13 pi over 12. Well, again, 13 pi over 12 is not one of our special angles on the unit circle, but is it a combination of angles that we do have on the unit circle? Let's take a look. Again, let's begin to write each angle with a denominator of 12, right? Because we want to be able to add or subtract them easily. Well, pi over 6, I can rewrite pi over 6 as 2 pi over 12. Pi over 4, that's 3 pi over 12. Pi over 3, I would multiply by 4 over 4. That's 4 pi over 12. 1/2 pi, well, that would be 6 pi over 12. Any combinations yet? Nope, not yet. 2 pi over 3, I want to multiply by 4 over 4. That gives me 8 pi over 12. And if I multiply 3 pi over 4 times 3 over 3, that gives me 9 pi over 12. And now we have a combination. Notice 9 pi over 12 and 4 pi over 12. These two angles add together to give us 13 pi over 12. That is pi over 3 and 3 pi over 4. Therefore, we can rewrite the tangent of 13 pi over 12 as the tangent of pi over 3 plus 3 pi over 4. And now we can use our sum formula for tangent to begin to simplify. All right, tangent of u plus v. Well, that's equal to the tangent of u plus the tangent of v divided by 1 minus tan u times tan v. This is equal to the tangent of pi over 3 plus the tangent of 3 pi over 4 divided by 1 minus the tangent of pi over 3 times the tangent of 3 pi over 4. Well, if we're going to evaluate the tangent of pi over 3, tangent of pi over 3, to evaluate tangent, we take the y-coordinate and divide by the x-coordinate. That's root 3 over 2 divided by 1/2, which is the same as root 3 over 2 times 2 over 1. Notice the 2's are going to cancel out, and we are left with root 3. All right, there's our tangent of pi over 3. To evaluate the tangent of 3 pi over 4, we take y and divide by x. The tangent of 3 pi over 4 is equal to, well, the y-coordinate and the x-coordinate are just opposites of each other. So that's going to give us -1. We can then plug those into the formula. We have root 3 plus a -1 divided by 1 minus root 3 times a -1. Adding a negative, that becomes subtraction, and multiplying a negative times a negative, that becomes addition in the denominator. Root 3 minus 1 divided by 1 plus root 3. Now, this is almost a good answer, except we have a radical in the denominator of our expression. So we need to rationalize our denominator. And to do that, we can multiply by the conjugate of our denominator. Multiply by 1 minus root 3 over 1 minus root 3. And as you guys have seen a lot in this chapter, we like multiplying by conjugates, right? Because when we FOIL conjugates, our outer and inner terms are going to cancel out. So we need to FOIL the numerator and FOIL the denominator. Again, I'm multiplying these two fractions. When I multiply them out, that leaves me with root 3 minus 3 minus 1 plus root 3. Notice that's the combination of our first, outer, inner, and last terms, divided by 1 minus 3. Again, notice when we FOIL the denominator, 1 times 1 gives me 1. The outer terms, that's going to give me a minus root 3. The inner terms, a plus root 3, add to 0. A root 3 times a negative root 3, that gives me a minus 3. All right, so we begin to simplify and combine like terms. Root 3 plus a root 3 is a 2 root 3. Negative 3 minus 1 gives me a minus 4. This gives me 2 root 3 minus 4 divided by negative 2. And now I can use the distributive property of division, divide each one of these quantities by negative 2. Notice that would give me a negative root 3 plus 2, negative over negative, negative root 3 plus 2, or we can reverse the order to put our positive number first, 2 minus root 3. All right, so there is a quick introduction to our sum and difference formulas and how we can use them to help us relate angles to our unit circle. Coming up, some relationships to angles that aren't specifically on our unit circle.